Hi teacher, we are going to explain the supply chain TOPSIS method. Our group is confirmed by Nicole Tapanta, Darren Moreira, and Carlos Llanes. Well, so what is the meaning of TOPSIS? TOPSIS is technique for order of preference by similarity to ideal solution. This method was developed by J1 and Young in 1981 as a ranking in conception and application. But what is a ranking? It's a ranking because we have some alternatives are chosen that simultaneously have the shortest distance from the positive ideal solution and the farthest distance from the negative ideal solution. In this case, we have some options, and with this method, we can put in order these options to make a good or to choose a good decision. So, what is the characteristics of the TOPSIS method? The ideal and the anti-ideal solution are fictitious solutions, and these concepts are so important because we know that the ideal solutions, all attribute values correspond to the optimal values contained in the alternatives. In this case, we have the best options or the better options than the anti-ideal solution that corresponds to the less desired values of each attribute contained in alternatives. In this case, we don't have a wrong decision, but we have the less correct decision. The method provides a hypothetically better solution, but also farther from the worst. Well, what is the methodology? To continue, those are the steps in TOPSIS method. The first step is the construction of the decision matrix. Starting from M alternatives, you can have some alternatives to make to your situation or to evaluate your situation. So to be evaluated from the criteria that we have the N and the following decision matrix is obtained, we can see what is the matrix, and in this case we can put in this position the solutions of the option that we have. The second step is the standardization of the decision matrix. The elements of the decision matrix may not define in the same domain and therefore have to be normalized. The norm used will be given by the expression we will call 3. This is the expression, and we can use this expression to a standardization of the decision matrix. The third step is the construction of the weighted normalized decision matrix. The decision elements of the weighted normalized decision matrix B will be calculated by the expression we can call 4. This is the expression, and we can weighted normalize this decision matrix with this expression. The other is the first step, obtaining of the ideal positive solution and the ideal solution, or in this case, the negative. The positive and negative ideal solutions, we are going to calculate it by this expression, the 5 and 6. And the fifth step is the calculation of the Euclidean. In this case, the Euclidean is the distance of each alternative to the positive ideal solution and to the negative ideal solution given by these expressions, the 7 and 8 expression. And for the last, we have the calculation of the relative proximity to the ideal solution. The relative proximity to the positive ideal solution will be calculated by this expression. And the last, we can ordering of preference. The alternatives will simplify by be ordered in decreasing order, starting with those that are closest to the ideal solution. That is the better or the best solution than the other solution that we can named or called the anti-ideal solutions. So we are going to explain this method with an example.
Well, now we're going to pass to the first example. For this, we are going to have like problem that is going to be we have to choose a mobile device that best suits the preference of a group of certain people. This will be like the sample group. Will be have variables that will be like the kind of phone. In this case, we're going to have iPhone, Sony, Motorola, Samsung, Xiaomi, and HTC. For the methodology, we're going to get the information from the select group and to have and they are going to tell us their preferences of each product to understand what they want, but we're going to have certain criteria. So this will be like the size of camera, the size of phone, the camera, the space capacity, the battery, the design, the processor, and the price. So with this, we can pass to the first step. That is, we are going to populate and we are going to get this information, and from each person having an scale that is going to go from 1 to 10, and for each attribute, and then we are going to put these criteria in couple to be compared and define which is more relevant to each person. Also, each person have to tell us from all of the smartphone uh, what they prefer. So first, we're going to have the decision matrix. In this case, we have the different criteria and the different kind of phones, and the punctuation that we have from each person. In this case, we are going to have to do the standardization of the decision matrix. That is, this is having the numbers divided by the total of each category. Then we are going to do the construction of the weight normalized decision matrix. We have here the criteria and how each person punctate the phones. Then we are going to obtain the ideal positive solution and the negative ideal solution. Then we are going to calculate the mean distance for each solution. And then we are going to calculate the relative proximity to the ideal solution. For this, we are going to have this calculation that we did before and divide for each segment, and this will give us a number that if is equal to 1 is the positive ideal solution, and this will be like the best solution. And if is not equal to 1, this will be the negative ideal solution. So in this case, is only when is equal to 0 that is going to be the negative ideal solution. So in this scale, we are going to classify the number from the lower to higher, and this will give us the ideal solution. In this case, we have the Xiaomi is the ideal solution that best suits the preferences of our group of people. So this is the final step, the ordering of the preferences. And then we can do like a graphic that is going to show us how we can visualize the best solutions.
Now we have the second example. For this example of supplier selection, we will consider a company that manufactures clothing, and this company will choose a supplier according to the price per meter of fabric, the delivery time, and the quality of the fabric. First, we have the decision matrix where we have the criteria, the weight of each criteria, and the three suppliers. And we can see in the Excel the second step that it is the standardization of the decision matrix. We can see here the formula we use to have the numbers, and then we need to do the weighted normalized decision matrix that um, we multiply this number to the weight of the each grid. Then we need to obtain the ideal positive and negative solution, and we only choose the higher and the smaller number of each category of each criteria. And we can see the three criteria and the positive and negative. Then we need to calculate of the Euclidean, and in here we take account the supplier, and we can see the formula. And finally, we calculate the relative proximity to the ideal solution. So we can see that the best supplier is the first supplier because it has the highest number of the meet of the criteria.